factoring to solve quadratic equations. In the previous notes, there was only one type of factoring that you did. In this notes, I mixed up the different types of factoring, and we're going to talk about different things that can happen. I might go through the factoring steps a little bit quick here because you've learned those. And the zero product property part, the new stuff, that's pretty routine. So I might write it kind of quickly, but that's not new either because we learned that yesterday. So this type of factoring, you are going to look for GCF and say, okay, this probably doesn't have a GCF. This is multiplying to this number, add to this number type trinomial. This one's pretty straightforward, so again, we're not going to spend a ton of time on it. I need numbers that multiply to 12 and add to 8. Yell them out, what are they? 6 and 2, right? You think 3 and 4, you think, you think 3 and 4, you think 1 and 12, but 6 and 2 add to 8. In the previous chapter, there was no equal sign. And it just said factor, and you just factored it and you were done. These don't say, factor only. They say solve by factoring. So you have to get the answers. And in case you're wondering why we have to do this, is because the square roots method doesn't work on these problems. The isolating way, getting x alone, doesn't work. So that's why you need this method. And these problems we did yesterday. If you don't know how to do that problem, if that seems like something you don't understand, you need to go back and either learn how to factor it or learn about zero product property or do the homework from yesterday. But that is stuff we talked about yesterday. 2 is the same thing. It's just a different type of factoring. Okay? Let me say this again. The reason I can't solve by square rooting both sides, solving by square roots, is because I have an x squared and an x. When you have an x squared and an x, you can't solve the way we did at the beginning of the chapter. In the beginning of the chapter, there was no x. There was only x squared. Then you move the things around and get x alone. But when there's an x squared and an x, you can't do that. So you look for a GCF. This one, there is no GCF. So that means that it factors into 2 binomials. This is a guess and check type. I have to find numbers that multiply to 15. In the back here, find numbers that multiply to 2. So I know it has to be 2 and 1. It's a minus problem, so I start with minus plus. The 2 numbers have to multiply to 15. And then again, I guess on these. I would start with 3 and 5 and 5 and 3. If that doesn't work, I would try 15 and 1 and 1 and 15. There's only 4 guesses to start here. Is this the right combo? Did anybody try this? You multiply, add. I'm supposed to get -1 and I got 7, so that is wrong. So I'm going to switch the 3 and the 5. This will come out different. All right, I get -5x, positive 6x. I add down, I get 1x. Is that the right combination? It's the right numbers in the right spot, but it's the wrong signs. So he said if you get the wrong number, like we got the wrong number in the last one, that's why I switched the numbers. But if you just get the wrong sign, just switch these signs. And now it will work out for sure. When you switch the signs, these all come out opposite. That's the right combination. That's the correct factorization. Is this problem done?
No.
No. That's just the factoring part. Okay? Now we do zero product property. This is the new thing. The hard part of this problem is from last chapter. This part of the problem is easy. Set both of those equal to 0, and then you get x alone. And I want you to write out these steps because I want you to understand them, long term. I'll tell you the shortcut. It's the opposite of this number, so -5 over this number, +2, -5 over 2. Now, these fractions never reduce if you do this right. The reason these fractions don't simplify is because the original problem didn't have a GCF. These don't have a GCF. If there's no greatest common factor, there's nothing to divide those numbers by and simplify that fraction. So those fractions don't simplify. If your fraction simplifies, you either did it wrong or it was a GCF problem and you should have done GCF and you did it wrong. So those fractions, if it's a problem like this, they will not simplify. And on the other one, just add 3 to both sides. You have to write the word or in between. We said there's almost always 2 answers to these problems. And if it's a second degree trinomial, most of the problems we did have 2 answers. We did one that had 1 answer. There are some that are not factorable that don't have any answers. Not because they're not factorable, because of other reasons. I would not give you a problem that says to factor it that's impossible to factor. So this one's factorable also. So I check for GCF. 3 has no GCF either, right? There's no number that goes into 4 and 9. 1 has an X. This one doesn't have an X. If there was an X right here, I would do GCF. But that doesn't have an X, so it's not GCF. This is difference of squares. Again, you learned this last chapter. You do the square root of these have to be the same. You do the square root of these have to be the same, and the signs are 1 of each. This one, by the way, could be solved by square roots. I could have added the 9, divided the 4, and done the square root of both sides. This way is actually easier in this kind of problem. One of the reasons it's easier is when you move the 9 over and divide by 4, you get a fraction that doesn't simplify, so that complicates things. The other reason is if you do it this way, you're less likely to forget that there's 2 answers. Where that square root way, people always forget, not always, but a lot of the time forget there's 2 answers. I'm going to get opposite answers here. So this is a difference of 2 squares problem. For these first 4 problems, I have 1 of each type. So we had the trinomial where you don't need to guess and check. We had the trinomial where you do have to guess and check. We have difference of 2 squares, and number 4 is a GCF problem. So you should notice it right away that you can divide these both by 4 and they both have an X. So it's a GCF of 4X. Says you'll do GCF problems wrong because before they even start the problem, they draw 2 sets of parentheses. So always check GCF. No matter what the problem is, look for GCF. If you could do GCF, you do it. And then you divide these both by 4x, divide by 4, take an x away, divide by 4, you get -2, take an x away. 0 product property, whoops, the calculator came up on its own. 0 product property. If it's a GCF with an x in it, one of the answers will always be 0. If it's a GCF, whether it's x or x squared or 4x or 10x or -4x, it wouldn't make a difference. If the GCF has an x in it, 0 is one of the answers. If the GCF was just plain 4, then that wouldn't be x equals 0. But if it has an x in it, you will get 0 as an answer. And it makes sense, right? If every term has an x in it, imagine plugging in 0. If every term has an x in it and you plug in 0, it makes everything 0. So of course it makes that side 0. So you have 1 of each type here. So this sheet has all the 4 types of factoring that you learned last chapter, and then we solved each one. And then I have mixed up problems here, okay? And we're going to work into this day 3 here. We might skip around a little bit, but we're going to do all of this. And ask me questions if you have them as we go. On number 5, if you don't do the first step right, you're going to have problems. Does anybody want to raise their hand? Because this one's a little different than some of the other ones we've done. What's the first step to this problem? Leslie? Yeah, you have to have an equal 0. So Leslie said subtract 4. You have to have an equal 0. Whatever this is, you got to make it equal to 0. And in this problem, you're not just moving the 4 over. It combines with this. That shouldn't be too unusual for people, right? There's a 20 there, and you're doing minus 4 to both sides. So 20 minus 4 is 16. So that's the step that you have to worry about. This has to be equal to 0. Whoops, I didn't mean to erase that. This has to be equal to 0. The whole purpose of the notes yesterday is to learn the 0 product property. And to do the 0 product property, you have to have a 0. For this problem, it's a trinomial that has no GCF, so I didn't do GCF. It's not a guess and check type. It's the kind we have to multiply to 16, add to -8, -4, -4. These are the same, so you don't do this twice. And we said you could get one answer, and there is only one answer to that one, and it's 4. And if you want to check this one, check it into the original, and I'll just show you the check. You don't have to get out your calculator and do this. But I would plug in 4 to the very original problem. It's the only solution, and this 4 should come out, right? It should be equal to 4, and so I wouldn't check into this line. I would check into the very original. And all the problems we did, you can check. You know, I'm not going to sit there and check every single one of them because people will get bored. Okay, on number 6. Sometimes these throw people off because they're like, okay, it's in factored form. What should I do? 6 is actually supposed to be easier. What you don't want to do is FOIL, because if you do FOIL, you will have to factor that, and it'll factor right back into this. This is factored form, and you already have the equal 0. So this is 0 product property. You don't need to factor. And sometimes people get confused on these ones because they think you need to do something more than just jump right into 0 product property. And you don't need to. If that's not a 0, you can't do what I'm doing right now. This only works if that's a 0. It is a 0, and so you just do this. And I know I'm going a little faster, but a lot of these steps are routine. And if you get behind on the notes and you don't feel like writing all this, you know, you could skip a problem here and there. I already told you the shortcut. It's the opposite of this number divided by that number. So it's -5/2 and +7/3. Those are the two answers. Okay. Now there is something that I need to tell you about that we've never mentioned before because it's never come up. And it's going to come up on number 7. Number 7, I need to move everything on one side. I need to get an equal 0. There's one thing that, you know, you are never told that you need to be aware of. It really helps if the squared term has a positive number in front of it. So even though it's easier to move this 9 over, what I'll end up with, don't write this down, is I'll end up with this if I move the 9 over. And I'll have a negative in front here. I don't want that. I don't want a negative in front. There's several ways to handle it if there's a negative in front. You could factor out a -1. You can divide everything by -1. You can multiply both sides by -1. You can move everything to the other side. But what I want to do is just deal with that problem from the very beginning. And even though I have to move 2 things, I am going to get the 0 on this side, so this w squared ends up being positive. I want the squared term to be positive. Now I got rid of this and I got rid of this. That's why that side's 0. These 3 things are just in a jumble here. None of them add together. So I have to rearrange them in standard form. So I moved everything to the left side. The left side's better because I want this front number to be positive. If it's negative, those guess and check rules that you learned don't apply. And like I said, if you do end up with a negative in front, there's multiple ways to handle it, but the best thing to do is just avoid it completely. This is a guess and check type factoring. This one's not a tough one. Oops. I need numbers that multiply to 2. Well, they can only be 2 and 1. It's a minus plus problem, so it's minus minus. It's either 1 and 9, 9 and 1, or 3 and 3. Before I finish this problem, any questions about anything I just did there or explained? Okay. Try to make the front number negative is the moral of the story there. I'm sorry, try to avoid making the front number negative. You have control over which side you move to, so move to the side that makes the front number positive. 3 and 3 end up being the numbers on this one. This check that I'm writing, if you've been doing these, you should be able to do this in, oh, I wrote the wrong number. You should be able to do this in your head. And if you're writing in pen, you know, this needs to go away. You know, this is not the answer to the problem, because this is the check that we factored it right, but this is not done. So you know, you could write underneath it, of course, but you know, you don't really need to write this at all. A lot of people now are just multiplying, adding in their head because they've done it so many times on the homework and on the reviews. And you know, there's a lot that you need to know in these problems. You need to know how to move things from one side to the other. You need to know how to factor. You need to know how to pick which type of factoring to do. You need to understand the zero product property. You need to be able to get W alone. There's a lot here. Move everything on one side to get equal to 0. Factor it, same way we factored last chapter. Do the zero product property, same way we did it yesterday. Any questions about any of that? There's a lot there. All right, on number 8, do you think I'm moving everything to the left side or everything to the right side? Left, because I want to make the x squared term positive. So I'm moving these both. And you know, moving 2 things is tougher than moving 1. I don't know why I keep writing W's. But you know, when you move something to the other side, if it doesn't combine with anything, it just becomes the opposite sign, right? That was a positive 20. Over here, it's a negative 20. That was a minus 4. Now it's a positive 4. This is another guess and check one. And you know, when I'm guessing numbers that multiply to 25, I would start with 5 and 5. If that doesn't work, I'll try 25 and 1. I don't know what's going on next door. Doing something against the wall. That's the gym. We need numbers that multiply to 4. And so it's 1 and 4 or 2 and 2. If you try 1 and 4, you get negative 5 and negative 20, which is negative 25. But if you try 2 and 2, you get negative 10 and negative 10. That's negative 20. Those are the same. Another thing I guess I didn't mention is don't do this. You know how you did that last chapter, you write squared? Don't do that. That will only serve to confuse people. We explained why you only need to do this once. And again, it's a matter of practicing this. You are going to probably make mistakes, like writing that squared or moving things to the wrong side. You find out those mistakes during the homework. You do the homework, you make the mistakes, you say, oh, I'm not going to do that mistake again. And you know, you learn from the mistakes. Okay, so I know we did a lot there. We're not going to do all these problems. We're going to skip around a little bit. So I want to talk about these 2 problems, and then I want to go back and do that other problem, and then we'll see how much time we have. This problem's not really a particularly difficult one. It's geometry, but You don't really need to know a whole lot about geometry to do this. It says triangle RAM is isosceles. You know what that is. With vertex A, find all possible values of x. So if it's vertex A, that's their way of telling you that these are the congruent sides and the line of symmetry would be down here. Isosceles triangles have a special vertex, the one that the line of symmetry goes through. So that's what they mean, that those are equal. So you just set those equal. It's the same thing we've been doing. See if you can get this in the position where you can solve it. Okay, I'll give you time to work on this. So what we were saying was, even though it's quicker to move this to this side, I don't want this number negative. We've never done problems where there's a negative in front and you have to do guess and check. We talked about how, if it's a negative, you do greatest common factor, but I can avoid having a negative, and I don't have to worry about greatest common factor. I should think about greatest common factor, but there is no GCF for this one. The front number is positive. This is guess and check. If that 4 is negative, those rules about the signs, don't apply, and it just causes more guessing and checking than what's necessary. I would start with 2x and 2x. That might be wrong. If it's wrong, I'll try 4 and 1. I try 3 and 5. This is 6x and negative 10. That's not right. Switching the 3 and the 5 wouldn't make a difference because it's 2 and 2 in the front. So switching the 3 and 5 is not going to be different. I'll try 1 and 15. I don't think this works either. That's 2x. That's negative 30. That's not even close. So that means that those front numbers were wrong. So I try 4 and x. Just because I would pick 2 and 2 first doesn't mean that that's the right answer. If 5 and 3 doesn't work, then I would try 3 and 5. I get negative 7x. Another one where you got to switch the signs. When I write these problems, I sometimes write them so that I know that they're going to have to switch the signs so we can keep practicing that. Okay, you're not done yet. You do that and you end up with the right factorization, but the problem is definitely not over. Then you set these equal to 0. And get x alone. I know it's a long notes today, but every problem takes a lot of writing, and if you don't feel like writing everything that I write down today, that's understandable. I got 4/5 for this now, or 5/4 for this. Now I can't just glance at 5/4 and know that this works. So I'm actually going to plug this in and try this triangle out with 5/4. 5/4 is 1.25. So I get a triangle that's 6.25, 15 minus 7 times 1.25, 6.25. I'm going to do that bottom one, 3 times 1.25 plus 20. Can't write. Let me try this again. 3 times 1.25 plus 20 is 23.75. I didn't really mean to make this problem where this one ends up being impossible, but this is actually a numbers that wouldn't make sense. Let's try the -3, so you can see that one. This gives me 36 on this side, 15. Sometimes people think the -1 is always wrong. Times -3. But this comes out to be 36. This is 3 times -3 plus 20, which equals 11. The rule on triangles is if you add two sides, they have to be bigger than the third. And in this problem, this one doesn't actually make sense. I get these two numbers are too small. Those add to much less than 23.75. So it ends up being the -1 is the only answer there. And I made that problem a little bit more challenging than it might have seemed when we started. There's a lot you would need to know in this problem. You would need to know what it means to be isosceles, how to set up the equation, how to solve the equation with factoring and zero product property. Then you would need to know how to check. And then you would need to know the rules about a triangle, what's possible, what's impossible. This number makes both sides equal, of course, but it doesn't actually make sense because you can't have a triangle with these side lengths because when you add two, they have to be bigger than the third. So what I like about that problem is that the -1 is the one that actually makes sense. So you actually have to try them both. Okay, 2 more problems, then we're done. How would you do number 4? Because number 4 is kind of like this problem. But the issue is on number 6, it's that equals 0, which was a good thing because we could do zero product property. But this is an 11. Do you think I could do this? Yes or no? That's not allowed. That number has to be 0. Can I move this 11 over? Is that possible? Anybody have any suggestion what I should do on this problem? No one's got any ideas. Now, what do you think?
Do FOIL?
Yeah, here you have to do FOIL. On that other problem we did, we said don't do FOIL. But on this one, we have to do FOIL. We have to multiply this thing out, then move over the 11, then factor it. It won't factor into the same thing. So this is just me doing FOIL. Just multiplying binomial times binomial, that's FOIL. Then I'm moving over this 11, because now I can move it over and it doesn't seem unusual. And then I have to factor this. Why don't you see if you can finish this problem now? And again, there's nothing new today, really. FOIL's not new. Moving that 11 over is just, manipulating an equation. That's not new. Factoring is not new. Zero product property is not new. And like I said, if you're in the notes and you're like, I am getting tired of writing, you can just write -8 and 4. That's the answer is -8 and 4. The more you could show these steps, the better. But if you get, through your notes, if you get tired of writing this, that's understandable. These are the 2 answers. And if you go to check them in the original. And I can actually do some of this in my head. If I plug -8 in, watch what happens. -8 minus 3 is -11. And then -8 plus 7 is -1. And of course, those multiply to 11. If I check 4, it's 4 minus 3, which is 1. Oops. 4 minus 3 is 1. And it's 4 plus 7, which is 11. And those multiply to 11 as well. So one of these numbers makes these -1 times -11, which of course multiplies to 11, and one of them makes it +1 and 11, which multiplies to 11. So I knew these numbers needed to be 1 and 11 or -1 and -11 to work. Okay, so scroll way back to this picture frame problem. We're finally going to finish this picture frame problem. We just did one like this. Okay, this is on page 6. Some of you might not have been here when we started this problem. And if you didn't get this, just write this part out right here. And then you could go back and copy the notes later. We set this up, but we said we didn't know how to solve it. We said, you know, it's in this format, but we didn't know what to do. But we just did one like this. And, you know, it's not easy. You have to multiply all this out, then move over the 80, then factor it, and then you will get the solutions. All right, let's do it. So I have to multiply this out. Again, if you don't feel like writing all of this, you know, the goal is to make sure you understand it. And I know I'm giving you a lot of writing today, and I'm writing it all out myself. So you have to multiply all that out. I would add like terms, and if you're fast at this, you can maybe do the like terms in your head and skip the step I just wrote and just get right to here. Then you got to move over the 80 because we said that has to be a 0. We also said that we want the number in front of x squared to be positive. That's a new thing that I've never mentioned until now, but you really want this to be positive. There was not a lot of GCF on this note. I think we did one GCF problem. So just be aware that GCF is a major thing in this chapter. And if you don't do the homework, you only have that one GCF problem that we did. But you look to see if this has a GCF and it doesn't. So there's a guess and check one. Again, I don't know what the answers are. I'm going to start with 2 and 2. It might be 4 and 1. For 35, I'm going to start with 7 and 5. If that doesn't work, I'll try 1 and 35. I think these are the right answers, though. I get 10x and 14x, and I get 24x, which is what I want. I'm not done with the problem. I made a mistake here, didn't I? Why didn't somebody tell me? You know, I just factored this right back to what I had because I didn't actually subtract the 80. Okay, well, I made a mistake. Let's try this again. So this should have been, was it -45? Okay, oops. If I make a mistake, tell me. It won't hurt my feelings. All right, so that should have been -45. All right, let's try negative or +9 and -5 for 45. 45 could be a lot of different things. 45 could be 3 and 15. It could be 9 and 5. It could be 1 and 45, obviously. 18x and -10. Oh, man, this is wrong. Okay, I really think that this is a 4 and a 1. That's not working either. Switch this around. Let's try 5 and 9. That's -36 and 5. Oh. Is it 1 and 45? No. 1, 15. Which I must be missing the right one. 15 and 1. 15 and 3, I mean. That'd be 12. That's not right. Let's go back to 2x and 2x. Okay, let's go back to 3 and 15. One of them has to be negative. I'm missing the right one. Did everybody figure it out? 4x minus 5. Let's try that. Okay. 4x minus 5, and this would have to be then 9. Did I do this one and just mess it up? Oh, okay. Wait a minute, but it's not right either. Okay, switching it again. All right, 2x and 2x, and 3 and 15. Negative 3 and positive 15. Okay, we'll eventually get this. All right, this is negative 6x and 30x. There it is. All right. See, I don't know how to automatically know these either. I guess a check too. I don't know why it's trouble with that one. I feel like I put that answer. I feel like that's the first thing I put down. I feel like that's the first one I tried. I must have just messed. Oh, no, I tried 5 and 9. Oh, maybe I never did that one. Oh well, we got it. Sorry that took so long. I'm gonna put decimals down on this because it'll be easier to check these. We were trying to do the width of the picture frame, and 1.5. And if people guess and check, they might have figured out that 1.5 to begin with. But 1.5 makes sense. Negative 7.5 would not be a measurement that would even make sense. It's 1.5 inches around that whole picture frame. And if you check that, that would make the picture frame 5 plus 1.5 plus 1.5, which is 8, and 7, which is 8 by 10, which is, of course, does multiply to 80 inches squared, which is, you know, like I said, if you guessed and checked, those are the numbers you probably would have guessed. But that could have been any number, so that's the answer to that one.